Let me pull up 2.4. And let me share my screen. Okay. So let's talk about tension. Let me work out this last example here from scratch. Then we come back, we'll do some problems over here. So, and give me 1 second. Just gotta pull something here in Dropbox, my phone. Sphere, physics, problem sets. There we go. Yeah, so tension is essentially, so we're going to focus on this part right here where it says tension. The pulling force from a everywhere the rope connects to something, there is an identical tension. So we do expect tension to be identical. It's just that usually what's going to happen is when you have different angles, you're going to see some differences, but that's for the most part. Happen. So let's look at the last example on this page. Again, we'll look at the climber again. And I did have you guys look up, but I just want to work out from scratch and have a video on it so you guys have that. And then we'll do some problems over here when we come back from the break. So, what's happening? So you have 2 ropes, T1, a second rope, T2, and they're both going to have their own tensions that they'll experience. You have the weight of the rock climber, which is right here, and the tensions are going to be going in this direction. You want to be going away from the rock climber because it's holding the rock climber up. So tension should go away, or it should point. That's probably a better way of saying it. Opposite so that it holds it up. So that's what we expect for tension. Now, we can break this down to the components. So I call it T1Y and T1X, T2X, and T2Y. And there are angles associated with them. So if that's T1, T1X, T1Y, the skinny triangle here, T2, T2X, T2Y, right angles, right angles. The actual values of the angles, 65 degrees, 80 degrees. Remember, cosine of 65 degrees will be T1Y over T1. So T1Y is T1 times cosine of 65 degrees. Here, and actually, I gotta do it. It was 4 times. Fun. Sine of 65 degrees is going to be T1x over T1. So T1x is T1 times sine 65 degrees. So let me take a little pause, give you guys a chance to copy. All I'm doing is just basic SOHCAHTOA for the triangle off to the left. That T1, T1x, T1y at 65 degrees near the top. Again, basic SOHCAHTOA. So we're going to be using this for sure, and this for sure when we do our force equations. Any questions about what I've done so far? Okay, again, my forces, the way the climber is going pointing down, the tensions of the rope are going away at angles, right? But then those tensions, I'm breaking down to perpendicular force, like horizontal vertical components like that, and using basic SOHCAHTOA to figure out what those are going to be. Then I'll probably do maybe a different color. We'll do maybe purple. Cosine of 80 degrees is T2y over T2. So T2y is T2 times cosine of 80 degrees. And of course, T2x or T2 is sine of 80 degrees. So T2x is T2 times sine 80 degrees. So we're going to be using these as well. So we call them our components because they're parts of T1 and T2. One's vertical, one's horizontal. And of course, using my basic trig rules to figure them out. Okay. So we're not out of the woods yet. That was just a lot of the prep work I had to do. The body diagrams, breaking that down T1 and T2. Now we're going to come down to doing the forces. Any questions so far before I start writing the force equations? Cool? Okay. So I'm going to erase my screen because I don't have enough space here. But I do know what I'm doing, so I think I know what I'm doing. So, okay. So here's the deal. If we balance out the forces, when you look at your horizontal forces, that's just simply going to be T1x, or you could probably write like this: T2x minus T1x equals 0. There's T1x, there's T2x. They go in equal and opposite directions. This is third law of motion, mind you. Equal and opposite reactions. Here's the thing, is yes, a rock climber is going to be moving horizontally. I know that. But right now, at this moment, the mountain climber is at rest. Is the rock climber moving? No. The rock climber is not moving at all. There's no motion. Of course, things will change once you start moving. The tension will feel a little different. Right now, there's no motion. There's no acceleration. There's no F net. So that's why you can set it equal to 0. They balance each other out. And so in this case, I'm going to have a T2 times, that was cosine of 80 degrees. No, sine of 80 degrees. Minus T1 times sine 65 degrees. Equals 0. And there's going to be some wacky numbers with that, which we'll work on in a sec. Your vertical forces. That's in the y direction. So this is the x direction. So you got these two pointing up. So T1y plus T2y. And you got weight acting down. Minus W. And again, this person is no motion, is not moving up or down. So there's no acceleration in that direction either. So that's what you said equals, they all balance out. It's all about balancing forces. That's T1 times cosine of 80 degrees. No, sorry, 65 degrees. Yikes. Let's get that right. Okay, come on, get away here. Times cosine plus T2 times cosine 80 degrees minus mg. We already know what her weight is. It's 535, so just say that straight up, equals 0. Now this becomes, this is the beauty about, this is why I love this stuff, because it forces you to use all the stuff you've learned in algebra. It becomes a system of equations. If I calculate, you definitely will need a calculator. So let's see here. Sin 80 is 0.985. Sin 65 is 0.906. You can do substitution if you want. Cos 65 is 0.423. Next one is cos 80, which is 0.174. I'll leave the 535 to the side. And then you can stack the equations. Or do substitution. I kind of leave it up to you what you want to do. Actually, I'd probably do substitution personally. And you solve for T1 and T2. Just so you know, in the graphing calculator, there is, I won't give you one quite this complicated because I think this is a little much. Well, I won't say complicated, just the math is a little crazy. I think what I might do is I might make some old choice and I say, tell me what your tension equations would be. Maybe that might be a better way of assessing this. I trust you guys can do a system of equations. So I'm not too worried about that. There's a way you could do it in the calculator, which we could actually do a little demo when we come back from lunch. But if we look at the answers really quickly here, so let me actually pull up the answer key. So you get 919 for T1 and 845. And I think that's going to make sense. If you eventually work it out, I think that's going to work out just fine for us. I'm kind of just doing the math in my head. So yeah, I think those should make sense. So what we'll do when we come back from the break, I'm going to go and clear this right now. And don't worry, I record so you guys can watch this later. We're going to pick some problems here. I'm going to kind of figure out what problems would be good for us to do. Maybe number 5 might be a good one to start with. Maybe 6. I got to think about that one. So we'll do some practice here for that. And then after that, we do some practice. Then we'll start getting ready for our test this week, which is tomorrow, obviously, in the afternoon. Okay. Any questions before we leave for a break? No? Okay. So let's come back. We'll say 12-ish, 12:05, we'll say. So that should be good. So about 30, 35 minutes. And yeah, that's what we'll do. I'll stop the recording right now.